Hello again. We are continuing our discussion on differential calculus by talking about rates of change. This is lesson 12.9, so let's get started. The derivative, as you recall, one of the notations was dy by dx. That's the rate of change in y with respect to x. But obviously x and y aren't the only variables that we can use. We can use other rates that can be expressed with derivatives, and let's talk about some of those. We can talk about the distance, and the variable for that is s. That can be measured in meters, and it can change over time, which is called t in seconds. So we can say that ds dt is the rate of change, or s prime of t is the rate of change. It's measured in meters per second, or meters times seconds to the negative 1. If you're blowing up a balloon or something like that, the volume of that would change over time. So let's say the volume was in cubic meters and the time was in minutes. Then dV by dt, or V prime of t, would be measured in cubic meters per minute, or meters cubed times minutes to the negative 1. All right, so just to give you an idea of how that looks with other variables other than x and y. So let's say I have the height in meters of a thrown object. And so the height is negative 4.9 t squared plus 14t plus 18. So t is obviously the time variable again, and the height of the object is going to be dependent on the number of seconds that have passed. Okay, so what was the initial height? Let's figure that out. What is h prime of t and what does it mean? And what was the maximum height? Okay, and we're also going to figure out what the ball speed was after 2 seconds, so using all of that stuff. So here's our solution to that problem. The initial height is at time 0. So if I plug in 0 into the original equation, I don't need the derivative for this. If I plug in 0, I just get 18. So the initial height of the ball was 18. The derivative is h prime of t equals negative 9.8t plus 14. Because the derivative of negative 4.9 t squared is just negative 9.8 t. The derivative of the 14t was just 14, and the derivative of the plus 18 at the end is 0, so I don't write anything for that. Okay, and what it measures is the change in height for every second, so per second. All right, to figure out where the maximum is, I'm going to figure out where the first derivative is equal to 0. The first derivative I've already calculated as being negative 9.8t plus 14. So if that's equal to 0, then the time is 1.43 seconds. So that's when it reaches its maximum height. And to figure out the height of the ball, or the speed of the ball rather, after 2 seconds, I'm going to look at the derivative because that's the rate of change. I don't want the height, I want the speed. So the rate of change in height after 2 seconds is negative 9.8 times 2 plus 14, and that is negative 5.6 meters per second, or meters times seconds to the negative 1. Okay, there are other rates. I can do cost in dollars, can change for the number of items produced, which I can label that x. So dc by dx, or c prime of x, it's measured in cost per additional item produced. The volume in cubic meters can change with radius, so I can use dV by dr, or V prime of r, to see how much the volume changes every time the radius changes. So here's an example of that first kind. We're dealing with profit now instead of cost for producing x items. So the formula for profit is 5x minus 2,000 minus 0.0001x squared. That's the formula for how I'm figuring out the profit. How many items can I sell to make a profit? What is p prime of x and what does it mean? And over what interval of x is the profit increasing? Okay, so here's our solution to that. Here's the graph. That's what it looks like. So if I use technology, I need to figure out where I'm making a profit, and the profit has to be any time that the y coordinate, or the p coordinate in this case, is above 0. And if I use technology to figure out where the x-intercepts are, they're at about 404 and 49,596. So as long as I'm somewhere in between those, then I am making a positive profit. P prime of x is 5 minus 0.0002x. That's what I got when I took the derivative. and it tells us the change in profit for each additional item produced. So it's the kind of rate of change of the profit. So if I set that equal to 0, the only time that that is equal to 0 is at x equals 25,000. So P of x is increasing everywhere between 0 and 25,000 on the x-axis. So that's just kind of a little brief overview of rates of change and how the derivative is involved in that. If you have any questions, please let me know, and I will see you tomorrow.